Hi, in this video we're going to be discussing evaluating functions. First of all, we need to know what a function rule is, because we'll be referring to this terminology. A function rule is simply an equation that describes a function. In the last video we learned about a function being exactly one element in the domain matching one element in the range. A function rule is an equation describing this. A function rule is similar to a machine. You have values that you input. The function rule determines then the output. For instance, in our XY tables, the X is the input. It would go into the machine. In this example, our function rule is 3 times X plus 4. So our input value for X would go in. Let's say if it's a 1. So 3 times 1, add that to 4, our output is 7. Or, our next one, we could try a 2. Then you'd have 3 times 2, which is 6, plus 4 equals 10. So in goes a 2, out comes a 10. Same thing if we put in a 3. It would be 3 times 3, add the 4, so you'd have 9 plus 4, output would be 13. As you can see, when it's written in the linear equation format, your input determines the output. These are also known as independent and dependent variables for that reason. When we evaluate a function rule, we're going to need to know the function notation for the function rules. Function notation simply replaces f of x, or the function of x, in the place of y. So instead of writing y equals 2x plus 1, we substitute the function of x equals 2x plus 1. Why this notation? In the last chart we looked about the input is our x. So in this situation, if we evaluate this function for x equals 6, we're going to place 6 in for x. So in this case we'd say the function of 6 is, and you put the 6 in the blank, so it'd be 2 times 6 plus 1. So the function of 6 equals 12 plus 1, function of 6 equals 13. So it's exactly the same as a y, except it's more specific as to tell you for which value of x. Okay, on this one we are going to find the range. If we evaluate the function rule f of a, the function rule says f of a is a negative 3 times a plus 5. So if we want to find the range of this function for this domain, in other words for these values of a, we would slide these values one at a time in for a. So down here I've transferred our function rule, and in the place of a, I put in our first item of the domain, which is a negative 3. That gives us our original equation, but we substitute the negative 3 in for a. So you have a negative 3 times this negative 3, add the 5. Negative 3 times negative 3 is 9, plus 5 is 14. So in our domain we had a negative 3. We found our range is 14. So on this one now we're going to substitute in 1. The function of 1 for this rule will be negative 3 times 1 plus 5. So you have a negative 3 times 1 is negative 3 plus 5 equals 2. Therefore, input 1, output 2. Then we do the same thing for the 4. Function of 4 is negative 3 times 4 plus 5 equals a negative 7. Input 4, the machine spits out a 7. we're going to apply our skills for evaluating functions. Is an iguana's length a function of its age? According to our data set in this table, we know at 2 years, an iguana measured 30 inches. At 4 years, 37. 3 years, 31. 5, 45. And at 4 years, a 40. As you can see, our domain is not in numerical order. So to do our mapping sequence, let's put these in numerical order from the lowest to the highest. I see that we have a 2, a 3. There are 2 4s, but we only list them one time each, and then 5. Range, we do the same thing. Our low value is 30. Then we go to a 31. The next highest is 37. I don't see any duplicate values. Add 40 to it, and then we're going to list the 45. We want to now match these according to their ordered pair. 2, you'll draw a line straight across to its corresponding value, which is 30. The 4 goes to the 37. This 3 goes to 31, which is straight across. 5, straight across to 45. And lastly, we have this value of 4, but it goes to a 40. Our original question asked us, is an iguana's length a function of its age? And we have found out, no, it is not, because each of the items in the domain should have only one, and exactly one value in the range. This one has 2, so the answer is not a function. Okay, let's test ourselves a bit. Got 2 different items. The top one. Which of the following is not a function? On these graphs, it would be simple to use a vertical line test. Going from the right to the left, anywhere this only hits one time. So this is a function. Can only hit this one vertically one time. Is a function. Must leave us with the option here. As you can notice, this is going to hit in more than one place all the way across. So this would not be a function. And the bottom item, we're going to find the range for this domain. Talking about this function. The function of x equals 4 times x plus 1. I went ahead and filled in some blanks here so to make it quicker for the video. So we're going to look, change my markers here. Going to look first if our domain is a -1. The function of -1 is a -4 plus 1, which comes out to be a -3. You have a 0.5, which is the same as 1/2. 4 times 1/2 would be 2, plus this 1. So our 0.5 would end up being 3. And lastly, we had a 3.7. So the function of 3.7 comes out to be 14.8 plus 1, which would be 15.8. Simply a matter of inputting our domain, and that way the output turns into the function of x. In our next slide, we are going to take a word problem. Let's break it down into small pieces. The story is a store bought a case of disposable cameras for $300. So they've already spent $300. Their profit is going to be based on this function. So the profit P on the cameras is a function of the number of cameras that are sold. So C will be our number of cameras sold. P is the profit. They're asking us here to find the range of this function when the domain is these values. So we're going to start by rewriting our function rule. P equals 6, and instead of C, we're going to input the first value of our domain. So 6 times 0 minus 300 would be 0 minus 300, which gives you a negative 300. 6 times 15 minus 300 would give us 90 minus 300. We're still in the negative numbers. The store has yet to make any profit. They have to sell more than these number of cameras. What about 50? If we say 6 times 50, that gives us 300. Take away this 300. And now we have broken even. In other words, they make no profit at this point, but there is also no loss. They have recouped their expense, which was the $300 of the original. At this point on, anything more than 50 will make a profit. And they ask us to try for 62 cameras. How much money will the store make in profit at this point? We have 6 times 62, which is 372. Take away the original thing that they spent to get the disposable cameras, and it leaves them with $72 profit. So this type function is very helpful in getting simple profit. If you spend so much on your inventory, you always have to take that away from the number of cameras that you sold. 6 in this case would represent how much they're selling the camera for. If they wanted their profit to come at an earlier time, they could charge more per camera. And then they could figure out, gee, I don't want to have to sell 50 of my cameras. Maybe I could sell fewer of them and make money quicker. This is the end of our video on evaluating functions.